So we learn about the binarization by binary. So you still remember the meaning of binarization? So this binarization means we want to make it the numerical value into category. So we want to change the numerical value into category. And the category is only two, 0 or 1. We call it this is binary. That's why the name is binarization. So to discretize the numerical values, we have some ways. For example, the domain knowledge. If you have the expert John Munga, then yeah, you can determine, okay, the threshold is 0.5. Or we can use the average, or we can use the median for the splitting value. We call it splitting value. For example, I have this data. I do not know what is this data, but I want to split. If it is higher than 1.5, then it is 1. If it is lower than 1.5, then 0. So if it is higher than 1.5, it is 1. If it is lower, it is 0. For the salary, so we can have this number 3,800. If it is higher than 3,800, then let it be 1. If it is lower than 3,800, then let it be 0. So 0 is low salary and 1 is high salary. Okay. So last Monday we reached this section. We can use the formula. So in the formula we can create either continuous C. C means continuous value. C is the categorical values, and N is numerical values. And you can click the new in order to create a new attribute. So you can see here. So in the formula, we can decide what is the attribute name. And we can also define what are the attributes that you want to create, whether it is numeric or it is categorical, text or date type. So let's say this is numerical attribute. So this is the command in Python, and we can apply to the operations. 0. So this is the decision. If salary is higher than 3,800. So if this condition is true, then it is 0. Else 1. So if the salary is less than 3,800, so it is 1. If the salary is higher than 3,800, then it is 0. Okay. This is for a numerical value. So we can assign number 0 or 1. For the categorical, okay, so if you can see here, the red color, N means numerical. So the green color, C means categorical. So if we have this same condition, okay, so with the same condition, 0 if salary is higher than 3,800, else 1. So we have two options, 0 and 1. But in the categorical values, we can have the optional. What is optional? This is how we can put the values in the table. You can see here, I put high and low. So high will represent 0 and low will represent 1. So if you click send, then you will see the new variable x. Okay. This is the salary below 3,800, less than 3,800. Then this is 1 and this belongs to low. This salary is higher than 3,800. And this category is high. Okay. Now, there can be multiple conditions. So there can be multiple conditions. So we have if and then else, and then we have if and then else. So the condition, the first condition, if the salary is higher than 6,000. Okay. So we can say this is top maybe. This is high salary. Else 1 if salary is higher than 3,000. So it means when the category is 1, it means the salary is in between 3,000 and 6,000. Else 2. So we will put 2 when the salary is lower than 3,000. So there are 3 conditions. The first condition is the salary is higher than 6,000. The second condition is between 3,000 until 6,000. And the last condition is less than 3,000. So we can put the comment of the syntax as this one. If salary higher than 6,000, it is 0. Else 1. If salary is higher than 3,000, else 2. So let's see. I will copy and paste this one. So it depends on you whether you want to create a numerical value or categorical value. Now I will make a new, for example, categorical value. The attribute name can be anything. For example, salary with 3 conditions. Okay. So I will do this one. 0 if salary higher than 6,000, else 1 if salary higher than 3,000, else 2. You can see now salary with 3 conditions. We can have 2. If it is lower than 3,000, we can have 1 if the salary is in between 3,000 and 6,000. And it will be 0 if the salary is higher than 6,000. We can also create the categorical attribute. So I'm going to create a categorical attribute. salary category, for example. So the salary category, I will do the same condition, but now I will have three kind of category. The category is high. Let's say the other category is medium, and the other category is low. So there are three categories. So I will set this one, and then let's see. And you will see if it is lower than 3,000, it is low salary. If it is between 3,000 and 6,000, it is medium. If it is higher than 6,000, then it is high salary. So we can make the category something like this. So you can use the condition with this command. So there are also some other kind of methods. We call it pinning. Pinning. Okay. So we have the pinning. Pinning or in the pinning, sorry. The pinning is to group a number or more or less continuous values into smaller number of pins. So we call pin. So we can decide how many pins that we want to provide. So let's say I have the equal depth or frequency, and I have the equal width or distance. So we will check one by one what is the meaning by equal frequency or equal depth and equal width or equal distance. Equal depth or equal frequency. Because equal depth or equal frequency, we will divide the range into n interval. So first we have the data. Let's say we have n data, and then we want to approximately same number of samples. So we have the data like this one, we have price data in dollars, and we need to create 3 pins. So we want to make 3 locations, or we have the 3 places. So this is the data. We have 24, 8, 21, 15, 9, 21, and so on. Okay. So we want to make it into a pin. We want to make it into 3 pins. Then first we want to sort the data. Sort the data means we want to sort it from the smaller to the higher data. So this is the minimum, this is the maximum. Now we want to create 3 pins. How many data do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So every pin will be 4 data. Every pin will be 4 data. Every pin will be 4 data. So the first pin is this one, the second pin is this one, and the third pin is this one. So because this is equal frequency, because every pin will have the same frequency. Every pin will have the same depth. So equal or equal means same. So it is good in the data study, but some categorical attributes can be tricky. We have another kind of pin. We call it equal width or equal distance. So when we go to the equal distance, we want to divide the range into n intervals. So we have the uniform grid, and we have the lowest value and the highest value. Let's say B is the highest, and A is the lowest. So N is the number of N in the wall of equal size, or we call it the uniform degree. It means, let's say I have this data. So I have this data again. So I can determine what is the highest value or the maximum, what is the lowest value, and how many bits do I want to create. So suppose I want to create 3 bits. Then I have this data. Again, this is the sorted data. Sorted data means we have 4 is the minimum, 34 is the maximum. So we can calculate the width because we want to find the width. The width means the maximum, which is 34, minus 4, which is the minimum, divided by 3, which is the pin that we want to create. Because we want to create 3 pins, so we put 3. So if we want to put the pin equals to 4, then this will be 4. Okay. So let's say we have the pin 1, pin 2, pin 3. So we will calculate for F10. So for until 30. Because we have 4, 5, 6, 7, 8, 9, 10, 11, 12, and 30. So we have 10 data. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So if the value is in between this value, then we will put in the pin 1. The second bit is from 14 until 23. So if the value is in between 14 and 23, 14 until 23, this one, it belongs to the pin number 2. The last pin will be 24 until the maximum value. This is 34. So we have the pin 3, which is 1. It is straightforward, but outliers may dominate the presentation. So if you see this one, yeah, this is only 3 data, this is only 3 data, but this one we have 6 data. So some data are not in the same frequency. So skew data is not handled well for this equilibrium. So we can do the discretize with orange. So we have the let me just call the file, and then let me just call the iris, and then I can do the discretize. So in the discretize, you can see we can use the natural pinning. So natural pinning means, yeah, you can just split into 2. You can have equal frequency. So how many pin do you want? So if you want to create 2, okay. Or if you want to create with the equal width, then it's also okay. And then you can choose which attribute that you want to make the pin. So if I want to make the pin for petal length, the petal length I would like to use equal frequency. For petal width, I want to use the equal width. Then you can do this one, and then you can see in the data table. So the data will be something like this. So the petal length now in between less than 4.35 and higher than 4.35. So some data, yeah, you can see here. It is higher than 4.35. this data is lower than 4.55. So final width of the system, this is higher than 1.3, this is lower than 1.3. So there are many other kind of discretization. Okay. So we can use equal with D2, ID3, MDL, plus chi-square, MVT, and so on. So there are many important methods, or we call it discretizers. So which one is the best? It depends on the data. Okay. So you want to learn two things. Okay. The first is the equal frequency and equal width, equal width and equal frequency. And still there are so many words for the discretizers. The other thing that I want to explain is the continuation. Continuation, what does it mean? Continuation means we want to transform the categorical data into numeric. So the basic idea is using dummy variable. So the dummy variable means we have 0 and 1. 0 is not true, 1 is true. Other projects, we can convert the categories into numbers. Then use those numbers to define new categories. So for example, we have this one, red. We have green, red, blue, green, red, green, brown, red. So when you do with the continuation, so I want to change this category data into numeric. So red becomes the column here, and then if it is red, then it is 1, and the remaining will be 0. So you can see green, blue, brown, here is 0. Let's say the data is green. So red will be 0, green will be 1, the other will be 0. Let's say blue. So this is 0, 0, and this is 1, and this is 0. And so on. So because this is the one method for continuation. The other way for the continuation is to assign numbers. For example, red equals to 1, green equals to 2, blue equals to 3, and brown equals to 4. So if it is red, then this is 1. If it is green, then it is 2. If it is red, it is 1. If it is green, it is 2. If it is red, it is 1. Okay. So there are several methods in orange. We call it one-hot encoding. One-hot encoding, its value is assigned into a column with a binary value. So the one that you see, this one, this is the example of one-hot encoding. Okay. So this is the example of one-hot encoding. First value as base. So select a value as the base before binary. So we can select, let's say the first value is red, then red will be the value and the other will be binary. Most frequent as base. So the most frequent value as base before binary. Remove means you just remove it from the analysis. So you will not use that attribute. Remove if more than two values. This meaning that the categorical data, the categorical values, if there are two values, so it means, for example, we have yes and no, then we have two values. If we have three values, for example, we have high, medium, low, then it means we have three values. Maybe some of the data we have four values. If we have four values, for example, we have red, green, blue, and brown. So we have four different values. So the meaning here is, if the value is more than 2, so this kind of attribute, will be treated as ordinal. Ordinal means order. So we have the order from 1, 2, 3, 4, 5, 6, 7, 8, and so on. Then maybe one, red is 1, and then blue is 2, and then brown is 3, green is 4, and so on. Or treat as normalized ordinal. So normalized ordinal, it is between 0 and 1. So let's see. I use the data here. Let me open the file. And then let me open the color data. So the color data here. Now we have red, green, blue, green, red, green, brown, and red. Now I want to do the continuous. So there are options here. Whether you want to keep the data as categorical, or you want to use the first value as space, you want to use most frequent as space, you want to use one hot encoding, you want to remove if more than two values, you want to remove, it means either it is two values or not, just remove it. Treat it as ordinal. So we will put the numbers 1, 2, 3, 4, or treat it as normalized ordinal. Now let's see one by one. If it is keeping the data as the original, so if we keep the data as original, so the data will be the same as original. Now, if I change the data to the first value as space, what happens? So you can see the column on the data equals brown, data equals green, data equals red. So where is blue? There is no blue. Why? If the data brown is 0, if the data green is 0, and the data red is 0, then of course I know this is blue. So I don't need to make the column blue. I can just check based on these three attributes. Okay. So for example, this data. The data number 4 is 0 and 0 and 0. And I know that the color is blue because all are 0. Maybe you think that this is not easy to understand. you can choose one hot encoding. For one hot encoding, then you will see the data blue, the data brown, the data green, and the data red. So if the data is blue, it is 1. The remaining are 0. If it is red, then it is 1. And the remaining are 0. So you can check this one. How many data do we have? So the blue color we have 1. Brown we have 1. Green we have 3. Red we have 4. Okay. Now we can choose the other option. Most frequent as this. Most frequent as this means I know that there are 4 red. The blue is only 1, the brown is only 1, and the green there are 3. So red is removed. There is no column red. And if it is 0, 0, 0, then I know that this data means the color is red. Okay, and you can check also if the categorical data has more than 2 values, then you cannot see the color because it has 4 values. If you want to treat it as ordinal means order data. Then you will see the numbers. So blue is 0, maybe brown is 1, green is 2, and red is 3. So it is the number from 0, 1, 2, and 3. And then we can also treat the data as normalized ordinal. Normalized ordinal means we have 0 for one data. This is maybe blue. And then the most frequent data, which is red, it is 1. And the other is in between 0 and 1. So you can see this value is 0.3. So it is 0.3. And the other is 0.6666. 0.6667. We want to split the data into 4. 1, 2, 3, 4. So the minimum is 0, the maximum is 1, and the other data is in between 0 and 1. The other thing for the continuation is the how we can change the numerical data. Sometimes we need to convert the numerical data into other numerical data. What does it mean? Why? Numerical data to numerical data. Why do we do this one? We have already numerical. Why do we need to convert to other numerical? So the basic idea is to normalize. Normalize means sometimes you know the salary. The salary, maybe the salary of the people is in between the treasure income in Korea. How much? One? Something. Okay. Then let's say this is the sensor for 1 hour. Okay. But there is one person he can get that money per hour. Is it logical? Ama no bagus. Not all people can get this money. Okay. Only special persons. He is very famous. He is very important person. So he can get this amount of money. So this data, because this is outlier. Because this data is outlier, so we cannot use this data directly. In order to use this data, so we need to do the normalize. We need to normalize the data. It means we need to find the representative number. So we want to find the numbers that can be represented in between 0 and 1. So if we have 1 is the maximum, so I want to know where are the values lower than 1 and where are the values higher than 0. So the other approach, we can have the normalize with the parameter equals to 0. So let's say the lowest salary is 1 per hour, and maybe someone can get back 1 per hour. So this is very difficult to check the statistics. Then we can make something like the normal data distributed. So the normal data, we want to put the mean as 0. And then we put all the data or person in between this range. Or the other kind of approach, we want to put the value in between -1 and 1. So let's see one by one. Let's suppose I want to normalize the data in between 0 and 1. So we call it this is min-max normalization. So min-max normalization, it means if we have a maximum value, so the maximum will be 1. If we have a minimum value, the minimum value will be 0. So we can transform the data phi prime equals to phi minus the minimum of that particular attribute divided by the maximum of that attribute minus the minimum of that attribute. So let's say I have V here. What is the minimum? 1,000. It's the minimum. What is the maximum? 8,000 is the maximum. Okay. So this is the minimum. This is the maximum. Then this is 0. And this is 1. Okay. Now I want to check what is the transfer value of 1,500. What is the transfer value of 1,250? What is the transform value of 6,000? So we need to find any value of this one in between 0 and 1. Because I know that the minimum is 0 and the maximum is 1. Then let's say if the value is 1,000, I can use this formula. 1,000 minus 1,000, it means the minimum, divided by 8,000 minus 1,000. So the new value or the V prime, this is the transform value, it will be 0. If I have the value is 8,000, so 8,000 minus 1,000 divided by 8,000 minus 1,000, so it means 7,000 divided 7,000. Then it is 1. What about the value 6,000? 6,000. Then we can get the value 6,000 minus 1,000 divided by 8,000 minus 1,000. So the new value will be 0.714. So here is the new value for the salary equals to 6,000. Using this transform value, we can figure out whether the data is near by 0 more or near by 1. Because it is easier for us to understand with the scale. So we can see here. Let's do the continuation. Okay. So in orange we have continuous system. But if you see here, there is a section for categorical variables. And there is another section for numerical variables. If your data is categorical variable, you can continuous with this method. If your data is numerical, then you can continuous with this method. Now, let's see. I will use the salary data. Okay. I will use the salary data. Which is this one. This one. Okay. So I will use the continuous. So I want to continuous the salary. Let's say I want to do the normalize to the interval 0 and 1. And I can open the data table. Now the salary becomes this one. The minimum is 0, the maximum is 1. And the other value is in between 0 and 1. Let's say I want to do the continuous when the center equals to 0. Mu equals to 0. So the 0 point, we can see the 0 point. It means if it is in 0, then some data it is lower than the average. This data is higher than the average. This data is higher than the average. This data is higher than the average. You can also do it the other. For example, I want to standardize to mu equals to 0 and the standard deviation equals to 1. And you will see the data now has been standardized. We have the mean equals to 0, and then the standard deviation is in between minus 1 and 1. So the data has been reduced into here. So this data is in 0.8, so maybe this is very high. This data is minus 0.7, so maybe here. This is low salary. So we have the standardized. We have the standard mu equals to 0. We have also the scale to transform the standard deviation into 1. And we have the normalized in between minus 1 and 1. We have normalized between 0 and 1. So this is the common approach for the continuation. So there are various approaches for this encoding technique. So you already learned about the one-hot encoding. You learn about the ordinal encoding. So the ordinal encoding means you put just a value between 0 until n. Maybe if there are 4 values, so we have 1, 2, 3. So in the order. There are different kind of techniques, some coding, helper coding, polynomial, backward, binary, and so on. Okay. So for your practice, I already give you data about the edge. So how can you transform this edge into this category? Okay, please practice by yourself. You know how to do the if function. So make it when the person is 10, the category is 10. When the it is 68, I want to know that the category is here. Can you do that? Can you? Kita distribusi. Jika so distribusi. Zona anjir. Siamnya to is. Okay, let's have a break. I will continue after the break.